This question belongs to algorithm subject and was asked in GATE CSE 1992. So the question states, complexity of Kruskal algorithm for finding the minimum spanning tree of an undirected graph containing n vertices and m edges if the edges are sorted is. So what is a spanning tree? A spanning tree is nothing but it is a subgraph of a graph, minimal subgraph of a graph which is a tree. Is a tree. So what is the meaning of tree? A tree means it should be non-cyclic. It should be non-cyclic. And a spanning tree generally has all the vertices, which means V vertices, and number of edges E equals to V minus 1. Now there can be many spanning trees possible. Suppose if this is the graph and the vertices are 10, 20, then we can have over here 30, 40, 50, and this is 60. So we can have various spanning trees like this one, or we can have like this one, but the cost will be different. This will have cost 10, 20, 10, 30, 20. So its cost is 60, and this one cost is 10, 50, 40. So its cost is 100. So the finding the spanning tree for which the cost will be minimum is called the MST problem. So MST can be done either by Kruskal algo or by Prim's algo. Okay, so what Kruskal algo says? Kruskal algo says each time get minimum weighted edge. So let us try to do it so that there is no cycle formed. So for this, what is the minimum weighted edge? Let us draw the vertices. So minimum weighted edge is 10. Now next minimum is 20. Okay, next minimum is 30. So this is our Kruskal algorithm, and in each step we need to make sure that there is no cycle formed. In this question there was no cycle formed by default, but if it was something like this, we have 10 over here, 20 over here, then we have something as, okay, let us suppose we have something 10 over here, we take this, then we have 20, so we take this, then we have 20 over here, so we take this, then we have, yeah, let us take the graph to be like this. We have 10 over here, we have 20 over here, we have 30 over here, then we have 40, then we have 50, and then we have 60 over here. So first of all we take the minimum is 10. Okay, then we take the next minimum, it's 20, then next minimum 30 is forming a cycle, so we do not take it, and we take the next minimum, which is 40. So in this case MST is 70. Okay, so this is the Kruskal algorithm. So it is asking what is the complexity of Kruskal algorithm if all the edges have been sorted. Like we do not need to sort the edges, we can directly pick them up. So in the case when all the edges have been sorted, then Kruskal algo, so this is a Kruskal algo, will basically boils down to the union find algo. Union find. Kruskal is basically done using union find, but we also need to sort. So how the algo will look like? Algo will look like something for each edge UV in our graph G. We will find if the find set, which is the particular set to which edge U is present, is not equals to find set of V. If they have different find sets, then we will do union of U and V. What's the complexity of this? The complexity of this equals to alpha into number of vertices. This alpha is called the inverse Ackermann function. Okay, and it's approximately equals to order of the number of vertices. Order of log number of vertices. Okay, this alpha v has a value equals to this. So for each edge, so how many edges do we have? For each edge we are doing this. What's the complexity for each edge? We are doing log v into log v into log v. So what's the acronym for E? It's the number of edges. So here we have m edges and the number of vertices are n. So answer is order of m log n, which is basically finding the union find for all the edges of the graph.